Good evening. Can everyone hear me? Yes, fantastic, fantastic. And do you see the confidence interval uh, title slide? Okay, great. Well, let's go ahead and move on, okay? I'm Dr. Reggie Taylor from the Office of Research and Doctoral Services. And again, I'll be presenting this session on confidence intervals. Many of the names I see were here last night and have been here for the previous weeks. And you'll note that we talk about and try to align what we do here in the evenings with some of your coursework. And even if you're not doing coursework, I mean, this is important information for research. And even if you're doing, for example, qualitative research, you still should be reading and reviewing your literature exhaustively, meaning that you will be reviewing quantitative and qualitative research. And so it's very important as we're getting to see how important it is to really understand that literature when we read it, okay? So what we'll do here is go through a few housekeeping notes. And remember, our focus here is to ease that anxiety. And if we do that, we've accomplished our goal here, okay? Let me let some more people in. Then we're gonna discuss the actual discussion that you have for that upcoming week. If you're taking the research course. If not, this is still applicable for anyone, involved in quantitative research, being reviewing research in literature or conducting a quantitative study, etc. Then, to get us started, we're going to talk about two concepts called populations and samples. And then we talk about that because in this assignment, you will be required to select a random sample in SPSS. And that's pretty much the only time we'll spend in SPSS tonight, just showing you how to run that procedure to get the random sample that you need, okay? And then we'll just talk conceptually about confidence intervals. What do they mean? When you look at them, what are you looking at? How do you discuss that? What sense do you make of what you're looking at? And then again, we'll point you to the quantitative resources, etc. Okay? So in housekeeping, again, this session is being recorded, and let me double check to make sure I did hit the record button. And usually the session is available within 24 hours. The session that we did last night is out on the YouTube site. So this first link here is my general YouTube page. So you'll see everything out there. The second link is our Office of Research and Doctoral Services webpage. It's not out there yet. It takes a little time to catch up there. So again, you can always go to the YouTube page and we'll take a look at that and you'll see where I have a host of other types of resources out there that may be helpful to you, okay? And remember, we mute our lines, be courteous to others. Excuse me, let me go back. Mute our lines and be courteous to others. And my responsibility to you are to provide a safe, friendly, and non-intimidating learning experience. And I hold that very sacredly, okay? And this is not a general statistics seminar, as you all know, so we just can't really open this up to all types of questions. Really, let's focus on the content at hand. And nor is it a complaint, a griping session here, okay? We don't have time for that. We're here specifically for what, the application or discussion assignment is about and to really help you understand those concepts, okay? And you always have the opportunity to complete this anonymous survey for me, okay? Now, as you know, we always show the slide on easing anxiety, and Melissa did not cry last night, so that's progress. And that's fantastic, and that's the way it should be. That's the way it should be, okay? So thanks for sharing that with us. But remember, we're trying to get you from over here to over here on the right. When you look at statistics, when you are faced with an assignment, easy anxiety, you want to say, okay, I understand this. I have some resources I can go to. And this is not all Greek to me. So let's get right into it. this is what you'll see. And it simply says using SPSS. So we know we're gonna play around in SPSS a little bit tonight. And I mentioned that I'm going to show you how to take that random sample from the data set that you select. Okay, remember, you'll select and use a data set. And I'll show you how to use SPSS to get that random sample. Okay, then we'll look at how do we calculate the 95% confidence interval for the variable that you select. And then how do you calculate the 90% confidence interval? Now, we're going to stop here because the 4 through 6 is the exact same thing, but it's just that you will be taking another sample of 400. Does everybody see that? So you'll just simply repeat the process for, and let me just draw a line of delineation here, just to make sure everybody understands. Okay? This is what we're doing. The only thing that's different is that we'll take a sample of 100 and you'll take a sample of 400 and do the same thing. Does that make sense to everybody? Okay? All righty. Then you're going to talk about posting some results and really explaining your understanding of confidence intervals. And that's what we'll talk about so that you can kind of know, what are the main things that one should understand and consider so that you can put that into, your discussion write-up. And again, I'll show you an example. We always use those exemplars and just kind of show you an example to get you started. Okay? And by that point, that anxiety should be eased and we should be happy campers. Okay? So now, the first thing, though, as you're starting to embark upon statistics, two key terms are populations and samples. Okay? Now, the population is a complete set of people, things, etc., from which you are going to draw a subset from, which is the sample. So, for example, if we looked over here, this entire group of people here is our population. Okay? But when we conduct research, we know we don't use the whole population, so we go in perhaps and get a sample. But whatever results we get from this sample, we are designing our research to make sure that we can infer these findings to the entire population from which the sample was drawn. Does that make sense? And we are going to go into a data set, first of all, and let's assume that the data set is all these people. We're going to use SPSS to draw out a certain amount of those people, for example. Okay, and that will be the random sampling. Okay, we good? Everybody understand that? And in anything we talk about, we gather the data from this sample, but we have to have some confidence that whatever we find, we can also say it's true in this population. And this is where you'll see that the confidence intervals will be very helpful in explaining that the sample that we select truly represent, and if not, how bad is it off or how close is it, etc., simply by confidence intervals. We all have heard of, we look at the news, CNN, Fox, whatever you look at, and they talk about political races, and they'll say somebody's ahead plus or minus, a margin of plus or minus so many points. They're giving you a confidence interval. We are pretty sure that this is what's happening, but we're not 100% sure. So we've got to really, let the reader understand that nothing is specific, but there is some always margin of error. But we want to be confident in what we say about, and this is a very important concept to understand. We want to be very specific about what we say about the population. Remember, we didn't use the whole population. We're only going to use a subset. So in quantitative research, there's a lot of things that we do when we design research. When we design our research, there's a lot of things that we do to make sure that this sample is truly representative of this population. And one of the main things you can do to combat a lot of threats to validity is random sampling. Random sampling kind of minimizes the bias or the highs and the lows, and we kind of get a good mixture of everybody. Okay? So that's important. And again, we'll look at SPSS to see exactly how we can use that tool to take a huge data set. We could have tens and hundreds of thousands of records in it, and just quickly, with the click of a button, draw a sample from that, and then start analyzing that data. Here it is, right here. Very simple process. What you will do when you're in SPSS is select data, select cases, okay? And remember, you'll have this presentation, you'll also have the slides. You go up to number 3, right there, random sample of cases. Okay? Down here, when we click in here, it says approximately what percent of all cases. Now, this is where you'll have to do a little bit of math. So if you had 1,000 records in the data set, you would then tell SPSS to give you 10% of that, and that would get you 100 cases. So you'll have to do the math based on, your sample, the size of the data set that you utilize. Everybody understand that? And then you'll figure out what percentage you need to select. And what happens is that SPSS then gives you that particular subset. Now, before I go further, let's just go, I think now would be a good time to go in SPSS. Okay, and let's just look at that right quick. It's a very quick procedure, and we'll just follow the steps. Okay, now let's look first in the data set. In this data set, this is the same data set we've been using, with the total perceived stress and all that type of stuff. But look at the records. Let's see how many we have. We have 439 records. So I'm going to take about 25% of that, because a fourth of that will be a little bit over 100, and that'll be fine. So let's look at how we do that, okay? Give me just a second. Okay, so let's do that procedure now. So again, data, select cases, okay? Now we're in the live view. And as you remember, I want to put my variable, if condition is satisfied, we don't want that. We don't want all cases, but we want a random sample of cases, okay? Now you hit sample, and then this is where you go in and put the number of cases that you want. So I'm going to say 25%, because that'll give me about 100. Does everybody see that? Now, when you hit continue and hit OK, it puts a filter here, and that just lets you know that you've done something. But let's go to the data view. And you see all these little slashes here inside with the numbers. It's filtered out those records, and it's only using 100 records. So for example, let's see. It's going to use record number 334. You see that? Because 334 doesn't have the slash in it. So it's filtering all that out, and it'll actually be 100 and something of these records when you go to do any analysis. Let's find another one here. 310 is going to be used, you see? So it's basically did the random sampling for you. You don't have to remove any data or anything. You just tell it, I want X amount of cases, and then anything you do after that, it's only going to use that random sample. Everybody good with that? Okay. So now we'll go back into the presentation. Give me a second here. And we're going to talk about confidence intervals now. So think about it. You're going to open up one of those data sets in your class. You're going to go down and say, okay, it's got X amount of records, and you'll figure out what percentage of that, will give you 100. You'll run that procedure. Then we're going to get some output, and we're going to look to see that information on the confidence intervals, okay? But let's talk about what confidence intervals are. Remember, our important focus is we know we'll be able to click the buttons and follow the slide, but once I get the output, what does that mean? What am I looking at? What is that telling me? Let's focus on that. Confidence intervals is simply that, a range of values, okay? A range. And what it is that this range of numbers between X and Y, whatever that number is, that range, and is likely to contain the value in that population. Remember, we took the sample, but the confidence interval is going to contain the value that we pretty much are confident really aligns and is appropriate in that population, okay? And it's really a margin of error. That's all that it is. How far off am I? How confident am I that I'm close to this mean? Remember now when we talked about means and medians and modes last, I think it was yesterday. Well, we're going to get a confidence interval for the mean. Remember, that mean that we calculate is only from the sample. But what can I say about that as it regards to the population? That's where the confidence intervals will help us. Now, let's take a second and look at that. Here we have a mean, an average. We pulled some data, got the average, and the average was 5. But that came from the sample. We know there's hundreds of other records in that data set that belong to the population. So what is the population mean? And that's why we use statistics to infer back to the population. And what we see here is a range, an upper limit and a lower limit. So look at this. 4.6 is obviously lower than 5. And 9.4 is obviously higher than 5. So that range is between 4.6 and 9.4. So all we're saying is that in the population, even though we only use the sample, in the population, I am 95% confident that the true mean is somewhere between 4.6 and 9.4. Does everybody understand that concept? I would really like to see some confirmation and let me know if there's anything I need to repeat. Because you will report this in your reporting of any quantitative study you do, and most people leave out this information. It's the most important information. Remember, if I ask how many of us is on this call, I got 28 here. If I ask 3 of us our age and I got an average, does that mean that the other 15 of us are around that average? We don't know. But I'll get a confidence interval to be, you know what, I'm pretty sure that the average age of the individuals on this call is this. And I guarantee you I would be pretty much correct. So for example, using my average age, my age of 18, I'm sure, that, the population will fall. Someone maybe 16 and something, maybe as high as 21. But that's just a joke, but that's what it means. Now, the other piece that's misunderstood, people say, I'm 95% sure of this. Well, what that means is that we repeat the study. In this case, what we're doing is that we're just taking 2 samples. But if we would conduct the study or do this assignment 100 times, each time we do a random sample, 95 out of 100 times, that true mean will fall between here. You see that? Suppose I only did the study 10 times. Well, that means 9.5 times out of that 10, that mean is going to be somewhere between 4.6 and 9.4, even though the sample mean is 5. That's the concept of confidence interval. So you're not really comparing it. You're not comparing it. You are saying that that is the range, that is the population mean, but it's somewhere between that range. When you do statistics, you'll never be 100% sure of any results you get findings. That's why we have certain things as the p-value, 0.05. You know, there's always got to be a room for, suppose in a random sample, let's say I am sampling GPA, and I do a random sample, and I get a nice spread of GPAs. But isn't it possible, and listen at me very carefully, isn't it possible, not likely, but isn't it possible that that random sample will only get me people with high GPAs? It's possible, isn't it? Isn't it possible that that random sample may only yield me people with low GPAs? It's a possibility. So that's why we are never 100% sure. So we have to report confidence intervals. And if you don't report confidence intervals in a quantitative study, your results are absolutely meaningless to me. Absolutely meaningless. You will simply just report them. Okay? So that's the concept of confidence intervals, you know, in a nutshell, without going into, you know, a lot of depth. So remember, it's a range of values. And in this case, the range, again, I'm going to go over this again. The range is from 4.6 to 9.4. And that 5 was sitting somewhere here as the average in the sample. But we're saying in the population is truly between here and here. Okay? That's it. And that means that 95 out of 100 times that we know that the true sample mean will be 4.6 to 9.4. Okay. Now, sometimes these ranges can be very wide. Think about that. Suppose it was 4. I'm trying to make it 4 here. 4.6 to 29.5. Is that really good estimate? That could be anywhere, right? So you want to look at that range also. So that range is wide. I'm like, well, you know what? You haven't really told me nothing. So pretty much it could be anywhere, right? So that doesn't help me. So again, it's understanding what you're looking at. You know, smaller ranges mean something, larger ranges may mean something, again, depending on the context of your research. But I just want you to understand conceptually what you're working at and what you're looking at and how to understand and interpret what you might be seeing. Now, another thing is the way to say it, that it's another way to describe a probability. You know, so for example, 100 times, 95 out of 100, that estimate will fall between that upper and lower value. That's the same thing I just said on the other slide, okay? 95 out of 100 times. That's why we call it the 95% confidence interval. When we change it to 90% confidence interval, which you will do in the application, you'll change it to 90%, right? The next time. And I'll show you how you're going to do that. And then what you're saying is simply that 90 out of 100 times, you see, for a 90% confidence interval. And so again, if I take a random sample, say I do it 100 times, 95% of the time, I'm going to be sure that that mean falls within that range. That's all that the confidence intervals mean. But it's very important information. Now, how do we do that? SPSS. And you're very familiar with this process. You remember we did analyze descriptive statistics? We've already done descriptive statistics, okay? But after the descriptive statistics, you'll hit the explore button, number 3. Okay? Now, in this case, I chose a variable called dissertation anxiety, and it was sitting over here as a possible variable, and I put it over here in the dependent list. Now, the other thing is, folks, what do we always talk about? The scales of measurement, right? Remember, if it's a mean we're calculating, it has to be a numerical variable. So you won't put college or gender in here and try to figure out what the confidence interval is. Everything will always go back to the scales of measurement. So you will put a numerical variable in here. You hit statistics, okay. And right over here on the right is where you will tell it, excuse me, the confidence interval that you want, okay, right here. So you'll simply have, it's the defaults at 95, you'll hit continue, run your procedure, and then you'll go back in, do it again, and just change that to 90, okay? And then you'll have the two reports that you'll need to discuss the 95% and the 90% confidence intervals. Now let's see what that output looks like. There it is, right there in front of you. You'll see the average score, which is the mean, was 7, okay? And you see the confidence interval, it was as low as 6.4 and as high as 7.6. So if we did this 100 times, I can tell you with confidence, 95% of those means will be between 6.4 and 7.6. Does everybody see that? That's what it means. And you remember from last night, I believe it was, remember we looked at kurtosis and skewness and all that. We looked at ranges. All this is descriptive statistics. But now the confidence interval is just another piece to help us understand. So remember, this tells us about the shape and all that, how far apart the range is, all that, the standard deviation. Just another piece of information to tell us how confident we are in this average that we got. So all of this means something, and we're starting to learn when to use that. For example, when would we use the median? Anyone care to take a stab at that in the chat? When would we use the median? Remember, we did that last night. Would I use this with the normal distribution? Not normal distribution. Fantastic. It would have that extreme outlier that may be skewing the data, and it's not the best choice to use. Fantastic. So you see how you're starting to apply all the information. Now it's not a standalone session here we're doing. This goes back to what we talked about, you know, last week or Monday or Tuesday, whenever we talked about this. It all should start making sense now. And you can see how you can take a look at some output now, and there's so much now you can talk about it. You probably wouldn't know what to say about output like this prior to a week ago. Now you probably have a lot to say. As someone said last night, they probably said too much. But that's fantastic because you know you have a lot to say. Data tells a good story. It tells a huge story, okay? So we're okay with this slide and understanding of that and what we'll be looking for the our discussion. Remember, we're going to calculate the average score for a variable that you select. It has to be a numerical variable. And we go through that procedure, and we're going to get a lower limit and an upper limit. And that means that 95% of the time, if we did this 100 times, it would fall within that range of the lower and the upper bound. Okay? Now, let's look at this. Perceived stress, I believe, total perceived stress variable. Now, what I have on the left is the 95% confidence interval, right here. And on the right is the 90% confidence interval for the same variable, okay? We just know the ranges are going to change. Now, the mean is the same, 26.5, 26.5. But how does the range change based on the confidence intervals? So what I try to do here is the red is going to represent the range for the 95% right here, okay? See that? And it tells you right there, 25.4 to 25.6. Okay, excuse me, 25.4 to, give me just a second to erase this. 25.4 to 27.6, you see the red. So basically what we see here right here again, and it's the same thing that I have up here, same thing. But notice the green, the 90% confidence interval. Same variable, same number of people, but look what happens, I'm sorry, with the 90% confidence interval. You see the range is narrower, it's not as wide, because we are not as sure. Because we don't know, as we get more people, or as we increase the confidence, we know that now I can give you better information. I can tell you that it could be here, but I can tell you that it's probably somewhere between here and here. You see how I'm more confident in what I'm telling you with the 95%? And we'll look at this again. We'll look at this again, okay? But you'll see that, again, the red confidence interval of 95% is wider than the green one, meaning that the higher my confidence interval gets, the wider the range is going to get. I have a bigger area to say, you know what, it's somewhere in this range. But if I'm only going to be 9 times out of 10, I can tell you, or 90 times out of 100, it'll be between here. But if we do it 95 times, it's going to be between here. Does everybody see that? That's what that means. Okay, so wide one, it's just that's it. It's a wide range. Now it's a lot you can infer about wide ranges also. Okay, now depending on what you're doing, and if the study's not designed well, or if the data just sits that way, that range could be wide, and that's not really helpful to a decision maker. Say you're going to budget something based on the average. Well, if the average is so wide, you don't really know how to budget, right? But if it gets narrower, you have a little better, you're much finer in understanding, how you can budget. Is my budget, so basically, is my budget between $1 million and $5 million, or is my budget between $1 million and $80 million? $1 million and $80 million, I don't know what it could be anywhere. So that's the conceptualization there of what we are trying to do, okay? Now, you will report your means, your standard deviations, and your confidence intervals when you're reporting statistical results. Yes, you will. And it's one other thing that you'll be talking about that you'll report, and that will be the effect size, okay? But yes, when you write your results, now not for the descriptive statistics here, but say you're going to be running some tests here in a few weeks, say a multiple regression test. Yes, you're going to report the p-value, if it was significant or not. If you're going to report the mean of the variable, you're going to report the standard deviation, you're going to report the 95% confidence intervals. Yes. Because you see how much more information it's giving. Because this is all about emphasis. You remember, we don't know the true population values. The confidence intervals helps us kind of put that in some boundary. That's what it does, okay? Now, that's pretty much it for what we have to do. But what I'd like to do is, once again, just get back into SPSS again, and just go through the live process again. Remember, again, you're going to be doing, to get your random sample, I'm going to go data, select cases, and now I'm going to take this random sample, and but first let me clear my, let me clear something here. Okay, so now we did it once with 95%. So let's do it with the 90%. So random sample. Let me just even change the number of about 50% of the cases. So I'm going to get a larger sample size, okay? About 200 and something. Now, you'll note, if we go back to the data view, that we have our marked out responses. And like, for example, 338 is going to be used, 339 is going to be used. But then we would go through the process of analyze descriptive statistics. And remember, you will hit explore. And in explore, you'll put your variable in the box. And here I looked at total perceived stress. So total perceived stress was sitting over here when you come up in default. In your data set, you're going to select that scale variable. You're going to click, put it in the dependent list. In statistics, again, is where we'll make our selection. You see, now I just go back to the 90% confidence interval. And I hit continue. And I hit OK. And that's the output right here. You see that? This is the output. You see the means a little bit different and things of that nature. And then again, what you do is you just highlight that, you copy it and paste it into a document if you know you needed to send it to someone. Okay? Is everybody okay with that? Think we could replicate that if we had to? Yes, no, maybe so. Okay. Now, let's do this. Now, let's open up a document here. Let me end the show. Let's just look at an example of an exemplar, perhaps. This is the discussion right here, as it is from the classroom. Okay. And we did the random sample of 100, the confidence interval for 95 and 90%. The blue you'll do, and then you would just kind of use the blue down here to discuss it. But notice how we talk about this, okay? And what we say is that you tell the variable that you selected, and I just said it's a continuous variable to make sure I don't make a mistake. Was selected, you know, for this assignment, discussion, whatever you want to say. You tell me you did a random sample of 100. Okay. Two confidence intervals were selected, the 95 and the 90%. You tell me what the mean and the 95% confidence interval was, and you tell me what the 90% confidence interval was. And then this is where we kind of discussed the higher confidence interval resulted in a broader range, whereas the lower confidence interval resulted in a more narrow range, okay? And then you say figure 1 is the descriptive statistics for the 95%, figure 2 for the 90%. And then I talk about that statistical significance as the question was asked, do I report that? Yeah, it can be misleading if you use it alone because there's always a matter of uncertainty. And how we address that uncertainty is with a confidence interval provides that information, okay? And then that would just be repeated for the second application piece or however you want to write this up. But the key is, give me just a second. The key is, have we done this? Have we done that? Fantastic. So it's not a very difficult assignment. Just want to read a little bit further and understand, you know, the confidence intervals, how if I change this, what it does. And you'll be able to look at the data and see, but you know what you're looking at now. A lower limit and an upper limit. And my population mean is somewhere in there. For example, there's 30,000, I believe, active Walden students. No way you're going to use all of them in a study, but if you get the right sample and say the average GPA score in Walden is 3.8, it's going to give you a range. The lower end may be 3.6, the high end may be 3.9 or 4.0, I don't know. But you know that if you went into the data set, in the Walden data set with the 30,000 students and did it 100 times, that 95% of the time, you know, it's going to fall between those upper limits. So the same concept applies to no matter what it is that you're measuring, et cetera, et cetera. Because now the next step is that when we start running these statistical tests, your correlation test, your t-test, your ANOVA, this stuff is going to be so simple for you. Now you're going to look at this output, you're going to understand it, when we start looking at the write-ups, you're gonna say, wow, this just makes perfectly good sense. And that's where we're trying to get. So this is a stepping stone process here, okay? And I didn't want to put too much into this session tonight, but does this make sense? Now we got to that anxiety stage, and we've got from here over here, okay? Now, what we have here is the next thing is that, of course, we always have the resources out at our ORDS webpage. Remember where the recordings will be. We also, we're not, this knowledge check, disregard that. I don't have a knowledge check here tonight for this. But then the survey for the session and any of the other sessions that you have attended, okay? Now, what we've done here, the main thing in housekeeping is that there'll be a recording that I will put out, and it will be in one of two locations, okay? We hope that we have eased the anxiety. We've looked at the exact discussion that will need to be addressed. And we understood that, we are trying to infer about a population, but from the sample that we select. And we know how in SPSS to get that random sample, okay? We understand the confidence intervals now is nothing but a range of a low end and a high end around that mean value that we calculated. And these are the links to the survey. And this link, I want to take you to this link now and show you something. That link will take you to a YouTube page that I have. And this I can put out here myself. The other ones that go out to the ORDS page is directed by Walden, and it takes a little longer. But remember last night we did the descriptive statistics. This is where it'll be at. Scales of measurement, all of the visual displays of data. So those are here. You'll see when we get into the other tests, logistics regression, and repeated measures t-tests. All of these are the tests that you'll be coming up doing. And if for some reason we don't have a session, I can't, be available, these pre-recorded sessions will be here. Does everybody see that? The pre-recorded sessions will be there for you to use. And that's just how you can get them, Justin, right here, okay? The other place that you can get them is at our ORDS website. This is Walden's proper. The other place is mine. But you'll go out here to the Walden website. And again, this is where you registered for the descriptive statistics seminar, okay? Tonight, we're doing the confidence intervals, but continue to look here. So these two presentations will go down here eventually on the ORDS website, and check back because there'll be more upcoming seminars here aligned with what you're going to be doing, hopefully, okay? Does that make sense how we've got this little ecosystem built up? I just want to make sure you know where to go to get things so that you're just not in that constant state of anxiety. Okay, that's the point, to leave you with resources. All righty? So you have a couple of places to get them. Now, the next thing before we forget is let's make sure no one leave before I put the presentation and the exemplar in the chat, okay? So give me just a second to find those. And then you acknowledge when you see them showing up in there, and we'll know that everyone has everything. Confidence intervals. So the confidence interval PowerPoint should be there now. And the discussion exemplar should be there now. And let me see something here. And there's another file that I put there. Let me double check this and see exactly what it is. Yeah, there's another file I put in there for you. And this will be very helpful. You can use it as a resource, maybe and cite it. But it talks about, statistical inference by confidence intervals. And this can be another resource that you can use. But what I did was just to focus on, when you get to this, of course, don't read this whole thing and you're not worried about how to calculate it because SPSS is doing that for you. But just kind of read here in this nature of the confidence intervals and kind of, get an understanding. And this will also help you, write that narrative piece of your application assignment. For example, it's going to talk about what the width means, etc. So it goes a little bit more in depth from what I talked about. But I just thought I'd found that resource and I said, let me, share that with you guys also, okay? So you should have enough to be dangerous. And you'll see, though, that once we start getting into hypothesis testing, you'll see that you are now well prepared to understand what's going on. And this will all make sense. And it's not just you're going to be jumping into, oh, run this test and do this, and you're just pressing buttons and have no idea what's going on. Because that can be the most frustrating thing in the world. Okay? So, my friends, I'm going to leave the classroom open again as normal for a few minutes and let you get some of this stuff out or chat amongst yourself. I'm going to go have some dinner. But again, hopefully this has been very helpful. Continue to check for the upcoming sessions, and we'll see you when we see you again. So have a blessed evening, okay?
It's Dr. Taylor.
Yes.
Before you go, it's Melissa Elliott. When we are writing about this, because it looks like the program calls it lower bound and upper bound.
That's a matter of text. Any way you want to state it. Any textbook you read, lower bound, upper limit, lower limit, upper control limit, lower control limit. You may see it called anything.
Okay.
But you understand, what it is when you see it.
I do. I just as far as, again, I'm an English teacher, so I care about what we
No,
call
I understand. Yeah, but that's to answer your question. Don't worry about that.
Excellent.
Now, if you have a professor that wants you to say upper bound, upper limit, you do what they say.
Yep. Thank
But
you.
your analysis and your understanding of it is going to be the same regardless of what they want you to call it. Make sense?
Yes.
Fantastic. Okay.
Question,
All righty, my friends. I'll see you next time. And remember, I'll try to be here to accompany you throughout this journey. I really need the feedback to continue to being able to do this. So again, if for some reason a week is coming up and you don't see anything in the upcoming seminars, check the recordings, because it's more than likely been done a previous term, and it's the same thing that we do here. It'll get you all the information you need to be able to be successful moving forward. Okay, so thank you very much, everyone.
Dr. Taylor, are you there?
Hello? Hello?
Sorry, I have a question.
Yeah, but it has to be very quick. I have to go here. What is that?
Like the way you selected the data from SPSS, you have like 1 million data. So if I want to select the sample I want to use, I just go to data, select sample, random
Yeah, you
sample,
just follow the slide. Exactly. Yes, exactly as on the
selection,
slide. Nothing
the
changes.
number of cases. All right, thank you.
Yeah, nothing changes. You just have to calculate the percentage of the cases that will equal, the number that you want. So for example, that I use, if there's a data set that has 1,000 records and you need 100, then that's 10% of that. So you would put the 10% in there. So you have to do the math to get close to the number that you need.
Right.
And then you just follow the slide or follow the presentation again, step by step. Nothing different from what we did here, or what you'll see on the slides. And that should get you going in the right direction.
Thank you.
All right, you're very welcome. Okay, bye-bye, everyone.